అందరికీ నమస్కారములు. సర్వేభ్య నమస్కారః. నమో నమః, గురుభ్యో నమః. Today is the fifth day of our series of classes on Vedic mathematics and also the last day. So we'll mainly concentrating on the question and answers or any queries. We'll start the session with paying respects to our country by reciting Vande Mataram and then Prarthana. So let us request Chala Chittibabu Garu to recite Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayaj Sitalam, Sasya Syamalam Mataram, Vande Mataram, Subrajyosna Pulakitayamini, Pullakusumita Drumadala Shobhini, Suhasini, Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
Vande Mataram. ధన్యవాదములండి Chala Chittibabu గారు. Thank you so much. Going forward, now let us request Sharma ji to chant Prarthana, please.
1 minute meditation. Three times Omkar. Om Gananam Tva Ganpati Ganghavaamahe Kavim Kavinam Upshavastamam Jeshthirajam Brahmanam Brahmanaspatanahe Shunvannuti Bhisid Sadhanam Om Shri Mahaganadhipatiye Namahe Om Prano Devi Saraswati Vajebhirvajanivati Dhinam Vitriyavatu Om Shri Mahasaraswatyai Namahe Gururev Gatihi Gurumev Bhaje Gurunev Sahasmi Namo Guruve Na Guru Paramam Shishurasmi Gurau Matirasti Gurau Mam Pahi Guru Jnananandmayam Devam Nirmal Sfatikakritam Adharam Sarva Vidyanam Hai Griva Mupasmahe Shruti Smriti Purananam Alayam Karunalayam नमामि भगवत्पाद शंकरं लोक शंकरं शंकरं शंकराचार्यं केशवं बादरायणं सूत्र भाष्य कृतौ वंदे भगवन्तौ पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेद विभागिने व्योमवद् व्याप्त देहाय दक्षिणामूर्तये नमः असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मामृतं गमय ओम शांति शांति शांति। मातृदेवो भव पितृदेवो भव आचार्य देवो भव अतिथि देवो भव। ओम सहनावतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ओम शांति शांति शांति।
धन्यवादः शर्मा जी, धन्यवादः. Now let us request Goutham ji to take over the webinar, please.
सर्वेभ्यो नमो नमः. So I will say these recurring decimal procedures we had done earlier, and how the recurring decimal procedure of the quotient and remainder is related to the binomial expansion of a expression of type of 1 by something 1 by A9, means 1 by 19, something by 19, something by 29, and then 39, 49, etc. Or when the this is yes, that was that this is the one which is connected to this 1 by 19, etc. The next also we have seen that how the binomial expansion of 1 plus x to the power minus 1, that also is related to something like 1 by 21, 1 by 31, 41, etc. So with this binomial expansion, anybody has tried all those exercises given on the my slides? Exercises that was these exercises. How many people have tried, so that any problem has come, we can discuss on that for a while. Then we can go to the today's topic.
Good morning, sir.
Yeah.
Yes, sir, I tried, but I haven't tried all the things. We gave big exercise because we did not try 29 by 61. We tried for 19, 13, 17 only.
Yeah.
Thank you.
17 actually, how did you do this with 17?
The way you showed us, sir, 2 means like 8. Like 1 by 7, we were taking 2, 9, na? 1 by 29 means 3. 3 we'll be taking and coming from the right hand side, we'll have 3 for 1.
No,
Multiplied by 3.
I asked that 11 by 17. This
8. You said 8. Now we'll take 8. Like we'll have a 1 and then 8. 8 multiply 8, 64. In that way you said, right? I haven't tried on calculator. I was just trying on the paper.
Did it work? Did it match with your calculator thing?
I haven't checked, sir, but as you said, I tried, that's all.
So anybody has answered that how to do this one?
Multiply by 7, sorry, 7.
Yeah,
7 by
yeah.
7.
So actually, thing is that either you have to something by anything by, suppose I put n, anything by, either it has to be 9 or positive method. This is positive method. or you have to do something by A1. Yeah, this is the negative method. Negative method is slightly more challenging. So mostly you can of course, if something is ending in 1 itself, then other way, this is the only way, one better way. So you understand the thing. So 11 by 17, how you made it then? 11 by 17 becomes
7 by 7 into 7 by 7.
7 by 7. Okay, so 77 by
144.
190.
190. So
190.
basically what we have to do, how you will start this how will you start this problem? How will you start this? Please tell me then.
N
So
by A9. N by A9. Yeah.
N
So
by
M will
N
be 75.
it
A
is a
will
odd
be
job.
11.
What you have to start with and with what you have to divide. You have to divide by what?
Minus 19.
Huh?
It's
No.
minus 9.
How you have to, what you have to divide? What thing you will divide? Start dividing, and by what? So the thing is 11 by 77 by 119 is my problem. Okay, I have to evaluate instead of 11 by 17 is same as 77 by 119. Am I correct?
Yes, sir.
It is the same fraction. Basically, it is the same fraction. Only it is not in minimized term. This is called it is minimized form. Minimized form. Okay, and this is not in minimized form, but the value is same. It is everything. This itself is this one. There is no difference between this. So in order to calculate 11 by 19, I have to basically, if I calculate 77 by 119, it will be all right. Now, before 9, what is there? Ekadhikano Purbeno. What is Purbeno here? What is my Purbeno?
11.
11 by Purbeno. Okay. Ekadhikano. So that means plus 1. Okay. That means 12. This I have to start multiplying 77 by what? Notation I am changing. I'm telling this notation I will use for this purpose. 12, isn't it? So if I start dividing, so I do 0 and point. This is I can do because everything will be in fraction only, decimal only. Now when I start dividing 77 by 12, what is my quotient? What is my remainder?
6, 5.
6 and 5. Because 6, 12, 6, 12 is 72, and then
5 is the remainder.
yeah, 6 becomes my quotient and 5 becomes my remainder. That makes it what?
66.
5 quotient, 56.
Yeah, 56.
56.
Now 4, 8.
4 and 8. So 12, 4, 8, 48, and then if I add 8, 8 is my remainder.
7, 0.
7.
2.
Then this is very peculiar. This is 70, or you can may not write this 0. So this is very peculiar. This if it becomes less 0, next time what will happen? Just it will change the role. It will be immediately it will be 0 and 7, isn't it? Am I correct? It will happen always. So as soon as 70 comes, that will lead to next one is obviously it will come because it is less than this.
Yeah.
Then it will 70. Do you understand what I'm telling? Am I correct?
Yes.
Now,
Sir, excuse me, sir.
uh,
Sir, how we got 7 and 0, 56 you
Zero.
said
12 times 0.
77 by, yes sir, 77
84.
by 12 we will get 6 and 5,
Uh,
77 by 12, then 84 we need to do, right?
56 became 56, so it is 4%, 8 remainder. It becomes 84. 84 actually is divisible by
84.
7.
84, okay. Now
No,
again
it's
7,
not-
how will go, sir? 7, after this 7 we cannot, 70 you need to say, sir, we need to divide to 70
no,
by 12.
Zero.
it is 007. It is 07, not 70. This is the
0,
uh, this is the first digit. This is the second digit already. 84, 56. This is the my remainder becomes the first digit, and quotient becomes the second digit. So 07 becomes 70, then 70. How much it is?
6.
70, 12, 6 are
5,
72.
5, 10.
5, 5 and 10. Because it can be, see, it will be always, it can be 2 digit also. It should be always, it will be less than, obviously. Now 105, it becomes how much?
9,
8.
8 and 9.
And then 9. So that will go, you just match with them. You don't have to do it. It will be, I think it will have something like, I forgot, 39, it is like this. 109. It will be, I think it will have about 100 and, I forgot, 77, with 17, 17, sorry. 17 will have a 16, sorry, 16 digits. I remember. 17 will have 16 digits. So don't have to go up to 16 digits. You have come up to this one. Or yes, you can 16 digits. So you can go up to, let us see, 8 digits. 1, 2, 3, 4, 5, 6, or 2 more. 90, then 98 is how much?
8.
8 2.
8 and 2. It makes it 28. Then one more.
2.
2.
2, 4. 2, 4.
Now if we find again 42, it will be 3, isn't it?
3.
3 5 2 3 5 2 9 4.
So 3, exactly. Now we can, if you say 3, you just match it, and then this will add up to 12.
9.
That means it is actually 7 here. No, 4, 2 becomes 3 and
6. 3, 6.
oh, sorry, 6. Sorry, 11, not 12. 11. Add up to 11. This is 11, and this is 9. 119. No, 119. I'm doing 119, not 12 with my digit division. This is 11, and this is the addition of the remainder, and this is the addition of the quotient. So you can now directly we can do it.
5 3
5, 3, no, not 3, 2.
2
5,
2
3, 2, 5, 2, then
9
9,
4
4,
1
1, 1, and again
7.
it goes to 7. It comes back to 7, and its remainder is 7. So it comes back to 77. The remainder also you do 8. This is 3, no? This is 3. This is 11. This is 4. This is how much? This is 1. This is 2, isn't it? And this is 9. So this finally it comes to, see,
Sir,
this
how-
2 plus 7 is 9 and 4 plus 7 is 11.
sir, how you are writing
How you are
this?
writing?
After the 3, 6, you have written 5, 3, 2, 11. How you are getting these?
I can do by the conventional way that I was doing. The dividing 63 when you divided by 5 quotient 3 remainder, again 35, then again 2 quotient 11 remainder. That you can do. But what I'm telling that we know that it has 16 digits. So halfway 8 digits. 1, 2, 3, 4, 5, 6, 7, 8, 8 digits. So after 8 digits, what I can do, it is 100. This 119 was my denominator. 119 was my denominator. It has two parts. One is with 9, another is before 9. One Purbeno. That Purbeno will be my addition of the remainders, and this 9 will be always my addition of the quotients. So when I already these eight digits I have already done. Okay, this. Rest of the 8 digits I can do by this way also. See, 9 minus 6 is 3 and 11 minus 5 is 6. 9 minus 4 is 5. 11 minus 8 is 3. That way I can directly put. Whatever you feel like. You can divide also by this thing, or you can. I said now right to left also you can do. It was 77 by 119. So 77 I can start with. 77 into 12 is how much? 84. 84 plus 7 is 91. 1 is put here, 9 is put here. 12 into 12 into 1 plus 9 is 21. 1 I put here, 2. That way also right to left also you can do. Finally I come to that where again you will get 12 into 6 is 12 into 6 is 72 and plus 5 is 77. We come back to 77. So we know where to stop. Then put a dot here and put a dot here. Am I correct? So this is the various procedures you can do. It has various properties, namely division, quotient and remainder this side, and the second digit and the carry, and from the right to left, the 9's complement of the quotient, they add up to 9, and the remainders add up to 11. So all these properties are discussed. So is it clear now? You will find that you will just practice it at the even you can after some time you can my course number is there. You can try all these. All these you can try. Okay. All these you can try.
Sir, you said you are going to share the PDF. Sir, you said you will share a PDF with us.
PDF I have already shared. I gave to Colin sir and he has shared already. Not exactly the
Okay, sir.
not exactly the full book. Not exactly the full book, but by the same organization. But the same institutions, they have made a PDF. Maybe some copyright issue is there, they cannot make it full PDF. So please purchase it. It is very money. It will be very handy, and it is very 200 rupees something, around maybe 175.
Okay.
So now the same problem 11 by 17. I could have done by another way. Do you remember what I told? 11 by 17.
Multiplying by 3.
Multiply by 3.
3 by 3. 33 by 7.
33 by 61.
51.
53 by 51.
51.
51.
So what should I start dividing by what?
33 by 5.
33 by 5 by 2. Here is do ekadhikano. Only Purveno. You remember? This is neither ekadhikano nor ekonunno here, only just Purveno. Because this is actually by the application of the 1 plus x to the power minus 1. This has nothing to do with, because it is, so it has nothing to do with anything to do with changing. So now 33 divided by 5 is how much?
6, 3.
6 and 3. Now, but it will be in bracket, you have to write something.
7.
No,
30 minus 6.
30 minus 6 is 4. Here the challenges will come actually. Then 2 and
Why you wrote 24, sir? After
huh?
you wrote 24, no?
Oh,
6,
sorry.
3. You
I'm
can-
sure. I was dividing by 12, no 12. Earlier I was dividing by 12, no. So, not that. Oh, 36. Please tell me
That-
how it.
You can divide by 5, no? You will get 7,
You will be dividing by 5.
7 and 5. 7 and 1. But you wrote 24.
No, it should be 21, is it? No?
30 minus 6.
30 minus 6 is how much?
Oh, 24, yeah.
24.
Now 24 you have to divide it by what? 5. So it is
4. 4.
now in bracket
40 minus 4. 36.
now 36,
7, 1.
7. So in bracket
69.
no, 1 7, no.
Minus 3.
So
No.
10
10
minus 7,
7. 3.
3, 0 3. 2 digit normally, right? No, 0
0, 3.
0 3 when we do, what happens?
6, 0.
Huh?
6, 0.
No, 0. Always less than 5 means anything less than this digit divisor. Divider is this one. So it is to be always 0. And the remainder will be that 30. Yeah. Am I correct?
Okay.
Okay. Now we bracket we write 30.
6, 0. 30. We are getting 6, 0.
6 0. Now the challenge comes. What challenge?
4,
In the bracket it becomes
4.
0 6. So it becomes minus 6.
Minus 6.
That minus 6 actually when you divide it by 5.
Minus 1. One minus.
Minus 6 when I divide by 5.
Minus 1, minus 11.
6
1
is how
minus.
much? Minus 6 is minus 2 into 5. Minus becomes minus 10. Then add with 4. Am I correct? This becomes 6, minus 6. Minus 6 is equal to minus 6 is equal to minus 2 into 5 plus 4. So therefore, minus 6 when I do it, it becomes how much? Minus 2 here. And which you can write like this. Minus 2 is my quotient and 4 is the remainder. That makes in bracket 42. Do you get here? This part, if you understand this one, your negative method will be through. Negative method will be very easy to you. See, problem starts with here. When it matches, even if it is 1, you can manage it. 1 and 7 becomes 0 and 3. But here actually, here it is divisible by 5. It becomes divisible by 5. So my remainder becomes 0. Remainder 0 will lead to negative. And when that negative number, when you divide, that gives you a challenge. But if you understand it properly, when minus 6 is divided by 5, minus 2 is my quotient and 4 is remainder. Because minus 2 into 5 plus 4 is minus 6. You start to understand. You always remember that remainder is never negative. Remainder is always positive. It's always plus. And this is quotient can be negative. So that's quotient is negative. Now, since quotient is negative, so far I was doing what? 44 minus 4, 36. 30 minus 6, 24. But here, so therefore, 40 minus 2 means 40 plus 2 it comes. So 42. Now, you understand this? This here everything got reverse, opposite. Now 42 when you divided by 5 is how much?
8, 2.
8 and 2.
2.
8 and 2.
28.
28. Then?
5, 3.
No. 28 itself becomes?
12.
5, 3. 28.
12.
No.
20
Here is
minus
negative method, so it will not be 28.
20 minus 8.
20
That's
minus 8. That means 12.
12.
So 12 becomes
2, 2.
2 and now,
2,
how many
2.
digits you have done so far? 1, 2, 3, 4. It takes more space because everything we are writing something in bracket. So you accordingly have to do it. 1, 2, 3, 4, 5, 6,
6, 8.
7, 8. It have already done. Now, rest of the thing, it is very tricky because the addition, of course, this is becomes 22 becomes 18.
20, 18.
Now, it will become
3,
3 and
3. 40 minus 3, 27.
27. I will erase this part.
Thirty-seven. 5, 5, 7. 2, 8.
$27. You write on your copybook. Write. Please do it. In the meantime, I also be ready. Then 33 becomes 27.
5, 2.
27 becomes 5. 5.
2. 2.
5. 5.
5. 15.
This becomes
15.
here you can match. See, 6 and 3, 4 and 5. See, 4 plus 5, 6, all is adding up to 9. Because 8, we have crossed 8. The 9th digit will be 9 minus the first digit and so on. 15, tell me. 3,
0.
0. Now you tell. I will not tell. Please do what to do.
It becomes 0, 10 minus 7.
Here you are not getting still. Anyway, you will have practice. It will be minus 3, isn't
Minus
it?
3, minus 3, right, sorry. Yeah, minus 3.
And minus 3 is how much?
10 minus 7. So minus 1 and 7.
Minus 1. Minus 1. Makes it 5. When you say quotient is minus 1, that means 1 vincula.
Minus 2. Minus 2 and 7.
Yeah, minus 1.
Minus 1, 2.
Minus 1, 2 is also right, yeah. Actually, there are two ways you can do it. It can be minus 2 and 7 or minus 1 and 5.
No, it cannot be because 5 is there. It cannot be, remainder cannot be more than 5. Minus 1
2.
into 5. Minus 1 into 5 makes it minus 5. Then you have to add to 2 to get minus 3. So this becomes in the bracket how much?
21. 20, 21.
21.
Here actually it will not match 9's complement because this is something in minus. So this will not match. Up to 5 had match, but this is 10. 10. So 7 plus 3 is 10. It becomes more than 9. And then next digit is minus 1. That makes it 9. So 11. This one is this much? 4.
1. 4, 1.
Then
6.
6.
So that way you'll find that it is also possible. So only thing is that here minus 1 minus came here. So this was 6 and after that minus 2. So 6 and 2 vinculum. You have to convert it to, it becomes 58, isn't it? 2 places you will be getting. And 3 and minus 1. So 3 and minus 1 means vinculum is equal to 29. You'll get like that. 2 and 9. So you'll match that, it will be earlier, like earlier. Okay, so I cannot spend more time. So it will be fine. You will just practice it. It will be very good. You will be expert on that. First you do positive one also, and then matching with then we can get second negative one. If anything wrong comes, obviously you will again revise that. So that I. Now today I will start with another topic. Periodicity I have already discussed that. Today I will start with divisibility rules. You know that without actual division, we can always understand something is divisible by another thing or not. When a given number is divisible by a smaller number or not. Smaller number we call divisor. Some dividend is divisible by divisor or not. We can see without making an actual division. So we know that very small thing everybody knows that we are even an odd number use. Even number means it is divisible by 2 and odd number means not divisible by 2. So divisible by, because 2 and 5 are component of my base. That base we are using, base is 10, 2 into 5 is 10. So this has actually this component. So this has a particular divisibility rule. That's very easy. divisible by 2 to the power n requires last n digit to be divisible by 2 to the power n. This is actually cryptic formation like this. So example is that if we have to divide by 2, if last digit is divisible by 2, then whole thing is divisible. So that we will know already. Similarly, if last 2 digits are divisible by 2, by 4, that means it will be divisible by whatever before is there. It will be divisible by 4 always. Okay, is 56 is divisible by 4. So therefore, the whole thing is divisible by 4. Similarly, if suppose 356, probably it is sorry. You have to see whether 356 is divided by 8. Then it will be divisible by 8. Okay. Similarly for 5. If it is last digit is 5 or 0, it will be divisible by 5. If last 2 digits are divisible by 25, the whole thing is divisible by 25. That way. So divisible by composite number demands divisibility by its factors. That is 42 is divisible by 6 because it is divisible by 2 and 3 always. 2 and as well as 3. And 135 is divisible by 15 because it is divisible by 3 and 5 both. Now I jump to composite number with divisibility by 3 and 3 I use. So divisibility of the divisor ending in 1379 has general method called osculation. So by osculation method, we know it is divisible by 7 or not. But 137 or 9 or not. And 3, 9, and 11, this we already learned in schools. You remember some people, excuse me, one minute. You remember how you divided this one? দিদি আমরা আছি ওপরে আছি ওপরে ঘরে আছি ঠিক আছে নিচে আছি নিচে ও নিচে নিচে আছে নিচেই দোকানটা আছে গেটের সামনে গেটে আছে না আছে সবই আছে রেট আছে sorry now 2 to the power n is you remember 2 to the power n means that 2 means 2 4 if last 2 digits are last many n digits that if n digits suppose I want to do by 16 how much it will be how many digits have to test 4 digits last 4 digits divisible by 16 means whole thing is divisible by 16 similarly for 5 suppose I want to do by 125 so how many digits have to test
2.
3.
3
500.
no 125 is 5 cube so last 3 digits I have to test for divisibility by 125 am I correct this is read it correctly so you will get the idea okay so I gave two examples only 2 examples for in case of 2 and 2 examples for 5 so others actually from derived from this one and simply composite number in general principle for composite number I have given here general principle for composite number that if the those for composite numbers if factors are divisible by that number is divisible by some factors say 6 it is divisible by 2 and 3 both so it will be divisible by 6 means 6 has two factors, 2 and 3. So if something is divisible by 2 and as well as divisible by 3, it will be divisible by 6 as well as. Like 42 is divisible by 6 because it is divisible by 2 and divisible by 3. Because 21 into 2 is 42 and your 14 into 3 is 42. So 135 is divisible by 15 because it is divisible by 3 as well as 5. So, so both are there. Now, divisibility by divisor ending in 1, 3, 7 and 9. This is a general method called osculation. And we learn from childhood only 3, 9 and 11. Those are special cases of osculation. Now, 3 we learned so far. What we learned for osculation in this 3 and 9, 3, 9 and 11. That a number is divisible by 3 if sum of all its digits is divisible by 3. You sum it up. All this sum, the sum of this becomes 24. If 24 is divisible by 3, therefore, whole thing is divisible by 3. In case of 9 also. A number is divisible by 9 if sum of all its digits is divisible by 9. For example, if this number, this big number, you don't have to divide it by 9. You have to only sum up all these numbers. It becomes 27. So 27. So 27 is divisible by 9. So therefore, this will be divisible by 9. You have learned already. How many people recall that we have learned this thing in school days?
Yeah, we have learned, yeah, that one.
Yeah, remember. In case of 11, what happens? A number is divisible by 11 if the difference of sums of alternate digits, even and odd position digits, is either 0, they matches actually, same sum, or divisible by 11. Then the number is divisible by 11. Because it's 9, 3, 4, 5, 7, 1. I don't have to divide it by 11 to check that whether it is divisible by 11 or not. I alternately sum. 9 is here, to 3 is here, 4 is here, and 5 is here, 7 is here, and 11 is here. That means that alternate 9, 4, and 7 on one side, and 3, 5, and 1. These alternate digits we sum up and we find that both are same, both are actually, both are not, either should be, they could be both are same, or we find that this is add up to 20 and this adds up to 9. 20 minus 9 is 11, which is divisible by 11. Therefore, it could be 22, it could have been 33, and very big numbers. It can be very big. One is 40, another is 7. So difference becomes 33. So that would have been divisible by 11. So here it is 11, or there could have been math. So then I gave him a small exercise anyway. Now, there's osculation method. This is the osculation method. What to do in general? A 2 or more digit numbers, in algebra I have put actually. This can be expressed in the form this one, this one that way. So basically, what I have to do? I have to find a smaller number called this format. Means that suppose a given number is there, say 343. I want to test whether it is divisible by 7 or not. I cut it for anything, whether 7, 13 or anything. So I have to cut it. I have to separate the unit digit from other digits. And I have to do the operation with some multiplication, something, or multiplication with something with the unit digit. And then either, depending on the case, either subtract it from the rest of the digits or adding with some rest of the digits. Like here I gave the example. So basically this actually means that suppose it's 343. What I meant here, that suppose it is 34, 10 into 34. Rest of the digit R is my 34. This number 343 is basically 10 into 34 plus 3. Am I correct?
Yes.
Yes. So I have to find a smaller number. In case of 7, it is minus 2, for example. In case of 7, it is minus 2. So 34 or say plus 5, either plus 5 or plus. So plus a multiplier. 5 is my multiplier or minus 2 is my multiplier. 5 into 3. That unit is 3, your last digit. So, or I could have done 34 plus minus 2. Minus 2 means minus 2 into 3. Or 34 minus 2 into 3. So 34 minus 2 into 3 is how much? In case of 7, I'm telling example I'm giving in case of 7. 34 minus 2 into 3 is how much? 2 into 3 is 6. 34 minus 6 is 28. 28 is divisible by 7. So 343 also will be divided by 7. That is the idea. Or say 34 plus 5 into 3 is how much? 15. 34 plus 15 is equal to 49. 49 is divisible by 7. Therefore, 343 also will be divided by 7. That is the idea. This means that T is equal to 4. R plus 5. I will tell you. So some algebraic proof I am giving. So without algebraic proof, nothing works actually. So those of you who are interested in that can follow that.
Could you tell me how that 5 into 3 came?
Where?
Before this.
Achha. Now,
Yeah.
5 is my aim, oscillator. 5 is called oscillator. Aim is called oscillator. So here 5 is my oscillator. I'm
Why 5, sir?
multiplying it. In case of 7, oscillators are either plus 5 or minus. There are two oscillators. Why that will be coming? In case of 7, it happens. And this 5 into 3 by 2, it is 49. So 34 minus 2 into 3 is 28. Both are divisible by 3, so it can be divided by divisible by 7, so it is divisible by 7. And how to get the oscillator? Oscillator you can get it. Oscillator you are getting by this one. This consider. 10 into 5 minus 1 is equal to 49. 10 into 5 minus 1 is 49. 10 into m. M is oscillator. This is m. One example of m is 5. So 10 into 5 minus 1, 49 is divisible by what? Divisible by 7. It is divisible by 7. So 5 will be oscillator of 7. Similarly, 10 into minus 1 is equal to minus 21 is divisible by 7 because it is quotient is minus 3. Negative can be negative. So therefore, minus 2 is also a, as I told, minus 2 is also a oscillator of, I told no, either 7 or 7 has 2 oscillators, or either plus 5 or minus 2. So this, in both the cases, it satisfied this formula. So when you come to work, you'll find. This is an example I have given. So in case of 7, we have two oscillators, either plus 5 or minus. I consider later. Let us consider on plus 1, plus things. 343 divided by 7. First, whether this is. So example this I already given. First, we find the oscillator of 7. We see that 10 into 5 minus 1, that is 49, is divided by 7. Thus, oscillator of M, oscillator M is 5. So once we find M, we execute the following process. 34.3, we divide this part, is equal to 3 into 5 plus 49, divided by 7. So it is also divided by 7. Let us say bigger number. 64724. So first I cut it like this. 6472 plus 4 into 5, 6492. Now I cut it again. 649 plus 2 into 5, 659. Again we cut it. 65 plus 9 into 5, 45. So it becomes 110. Do like this. 11 plus 4, 11. Not divided by 7. So going back, tracking back, this one, all the whatever number we got, nothing is divided by 7. Let us check, take the divisibility of divided by 13. Oscillator of M is equal to 13 because we find that 10 into 4 minus 1 is equal to 39. Divided by 13. So therefore, M is equal to 4 in case of 13. 10 into 4. This is important. 10 into how much? Minus 1 is divisible by 13. So 39. Actually, it is, in short, earlier in case of recurring decimal, we did similar thing. You have to, there is similarity between these two. See, hint. Multiply numbers ending in 3 and 7 by 3 and 7 respectively to get something is ending in 9. So therefore, you will get that oscillator. So somebody gets 7. I cannot test going on 10 into 1 to 2 plus 1, 10 into 2, 3 plus 1, 10 into 4 plus 1, 10 into, sorry, 10 into 2 minus 1, 10 into 2, 3 minus 1, 10 into, like that, 10 into 5 minus 1, not that. 7, you directly multiply by 7, we get 49. 49. So aim will be that ekadikana purbe now. That is also another method. So 5 becomes my oscillator. It is a positive oscillator. Similarly, 13. 13 immediately how to make it end in 3? So 13 into 3 is 39. Okay. It doesn't depend with how much you are multiplying, but you have to define how it comes to end in 9. Ekadikana purbe now. Plus 1 is 4. So 4 becomes my oscillator for 13. Now how we will apply it to oscillator by 13? So suppose I have to test this number. 11635, whether it is divisible by 13 or not. So I cut it. So 1163 plus 5 into 4, 1183. I cut it again. 118 plus 3 into 4 is equal to 130. And you can see easily it is. Don't have to go there. This is not required. Because 130 is divided by 13. You can see if it is ending in 0, obviously 0 is no same as this one. So it is divided by 13. Since it is 13, therefore all these numbers, all the intermediate numbers are divisible by or intermediate steps also, including the first number, all are divisible by 13. Test whether this number is divisible by 23. Instead of dividing everything by 23, I do this 23 into 3 is 69, and 69 is 10 into 7 minus 1. So therefore, ekajikanu purban also 23 into 6 is 23 into 6 is 23 is into 3 is 69. 69. Ekajikanu purbena, this is becomes 7. So 7 is my oscillator. So what I do? 41285. Maybe that I'll maybe change. This was the original procedure, because from algebra demands this one. But how to get it? How to get it, that we know from our earlier methods of ekadigan and applying ekadigan purbena. So you don't do it. The oscillation method itself is a Vedic method. So that Vedic method is coming. Earlier it was not say 2, 5. All these things were not. It was also conventional mathematics. Also, you know. But this particular oscillation method, like we are cutting this number, dividing this unit, separating the unit, and then I am doing a smaller number I called it T, test number. Test number I am doing this one. Again cutting the text number, and again doing this oscillation method by multiplying these things and coming to this one. This is called oscillation method. Now, one after another. So then finally 92. So 92 is divided by 23. So therefore this one, this one, this one. Now one of you tell me, how did you do it? You can read it and do it. Please to understand that why you have understood. Suppose I'm testing the divisibility of 23. Divisibility by 23 of 41285. How I am doing? Please tell me.
You find the oscillator first
Oscillator.
for 23.
What is the oscillator?
7. Because 10 times 7 minus 1 is divisible by 23.
Exactly. But how we get it more simply? Because 23 is ending in 3. Immediately you multiply by 3. So that it becomes ending in 9.
9.
And ekadikano purbeno, that it becomes 69. So ekadikano purbeno is 7. So that also, that is another method. Now you
Yes.
tell me what to do with the oscillator.
How to find out the oscillator, sir?
Huh?
What is the how you are finding out the oscillator?
Oscillator, your participant told that it's 2 ways are there. So we find that 7 into 10 minus 1 is equal to 69. 69 is divisible by 23. Therefore,
Yes.
7 becomes my oscillator.
Oh.
Something better. But the simplest way is that 23 is ending in 3. I told you that. Multiply numbers ending in 3 and 7 by 3 and 7 respectively. In case of 3, it will multiply by 3. In case of 7, it will multiply by 7. So 23 when multiplied by 3 is equal to 69. So ekathekane purbena of the purbena 9 before 9. Purbena of 9 is 6. 6 plus ekathekane. So it's 6 plus 7. 6 plus 1 becomes 7. So this 7 becomes my oscillator. Now how to understood? Now how to handle with that 7? How to find the test number from the original number? So these are the step by step test numbers. So 41287. What 41285? What to do after that?
Take
What
5 and the oscillator.
I separate it first. I separate the unit digit from the rest of the digit. This is my R, I told you. Rest of the digits, and this is my U. 5 is my unit digit. So I separated it and multiplied the unit digit with oscillator. Then added it. Okay, becomes this. Again I separate. So rest of the digit, here also this is the rest of the digit R. This is my unit digit. I multiplied by oscillator, this A oscillator is M I given. O actually looks like 0, so not even this. This is my,
That is
so always the test number becomes smaller, obviously. So for the 37, again I do like this. 43 plus 7 into 7. 7 was my oscillator. 7 is my oscillator. And 7 is the unit digit. This is my rest of the digit. This was the rest of the digit. And this is my unit digit. So I separated it. So I multiplied by the oscillator, the unit digit, and then added with the rest of the digit. So
43 plus
92 is divided by 92. I could have done again, but not much difference will be there because 92 is plus. I can do it. 92 is 9 plus 2 into 7. Now 2 plus 7 is 2 into 7 is 14 plus 9 is 23 itself. It will lead to 23. 23 if you do again, how much it will happen? 3 into 7 is 21 plus 2 is 23. It will always come back to 23. So that is the procedure. You understood the procedure?
Yes, sir.
Positive, negative, and minimum oscillator. Sometimes the positive oscillator becomes very high. So oscillator for say in case of something you divide it by say something ending in 1, you have to divide multiply by 9. Again that same problem comes. So therefore I have to use if 10m plus 1 same way is divisible by something the algebraic consideration what I have done earlier with algebra. Okay, this also equally holds good. If you suppose 10m plus 1 is divisible by 10m plus 1 is divisible by something. So m becomes my negative oscillator. I can use minus m in that case. I'll give the example. So 10m plus 1 is divisible by d. All the algebraic consideration holds good. So in that case, you have to do r minus n. Instead of r plus m, you have to do r minus n. So I'm giving the example. And whatever is the minimum is called the minimum oscillator, and normally will be always like to do minimum oscillator, like to use. In case of numbers ending in 3 and 7, we have to multiply by 7 and 3. Earlier you have to use or doing the by 3 and 7, but here to do 7 and 3, so that it becomes ending in 1. So say for example 21. So in case of 7, I have to do 7 into 3 is 21, isn't it? 21, and this 21 is divisible by 7, obviously. So because then 21 is 20 plus 2 into 2 into 10 plus 1. This plus is important. Earlier it was something say minus 1 I'm checking, plus 1 I'm checking. So therefore 2 becomes minus 2. Opposite of this side. Minus 2 becomes my oscillator for 7. So how we are doing? Suppose I have to check whether this is the result. So this is this becomes my oscillator. So 5 obviously, and then absolute value of positive and negative oscillator becomes 7, divisible by 7 or 7 becomes. So 398. So I could have done this one also. I gave the example of 343 earlier, no? So we cut it like this. Then I try to come to that. 34 minus 2 into 3. Minus 2 into 3.
6. Yeah.
Is equal to 28, isn't it? And 28 is divisible by 7, so therefore here 343. So I apply here. And now, oscillated for 3 and 9 is 1. And oscillated for 11 is minus 1, because it is 9 is actually 9 is obviously it is 1 into 10 minus 1. So 1 is my oscillator. So that means 1 is oscillator means multiply unit digit with 1 and add. So that means add everything. And similarly, 11 is equal to 10 into 1 plus 1. So this 1 is there and this plus is there. So my oscillator is negative 1. So therefore, well, alternatively, we are it will always whole thing into minus 1. Keep on minus, subtracting the unit digit of the rest of the digits. So that means it will be alternate digits we are doing and adding and seeing. So you just think and it will be here. More examples I have not done. Let us see. You please tell me what you want to test with, say negative, using negative oscillator. Suppose you tell me any number you give. Let me. It will be. It will be interesting when something is really divisible. That will be better. Give me a number. Suppose I want to test divisibility by, say, 27. Okay. Say 1.5 or say, okay. I want to test whether this is divisible by, whether divisible by 27 or not. Now, oscillator of 27 is how much? Ending in 7 will be
7.
multiplied by 3 is equal to
17 or
81.
9.
No, not 9. It will be 10 into 8 plus 1. Now, 10 into 8. 10 into what? So this becomes my oscillator. But plus or minus, if it is plus, it is be negative, minus. And if it is minus, then it will be plus. So my oscillator is minus 8. Okay.
if you multiply by
Oscillator number?
7,
Huh?
if you multiply 27 by 7, we can go to 169. That
Oscillator
also,
is very big, no?
yeah, it is
Therefore, I
big.
told that positive, negative, and minimum oscillator. Positive, negative, and minimum. Positive, negative, and minimum oscillator. Oh, that I cannot come back. Okay, what I told? 1512, no? 1512. So oscillator was negative, 27 for 27. Oscillator how much? Negative, no? I told you 81, and then it is 27 into 3, 81. 21 into 3 is 81. And 81 is equal to 10 into 8 plus 1. So oscillator is minus 8. So
Yes.
1512, 1512. I cut it. it becomes how much? 151
minus 16.
minus 16 is how much?
135.
135. Now I do this arrow. Arrow you write because this is the from this one to this one. So 13 minus 8 into 5 is how much? 40. So this becomes minus plus doesn't matter. Minus 27. Minus it comes to minus 27. So minus 27 is divisible by 77. So this number or 151 also, sorry, 135. Both the 135 and 1512, they are all divisible by 27. Okay. So that was the idea.
Yeah.
You got it, no?
Yes.
Now here I give this table of positive and negative oscillator. So you will see that. 3 and 9, their oscillator is +1. This is negative oscillator. For 11, this is 11. It is this actually I have given the table first. This is actually a, just to show that 10n minus 1 and these are to find the numbers. So I find 11 here. 11 is actually my this is 10 into this is the 1. N is 1. N is 1. So 10n, this is 10n. 10 times this one. So now 9 is here, 90 will be here. And 90 minus 1 is 89, 90 minus 90 plus 1 is 91. So therefore 91 is here. So 13 will be negative oscillator is 9. But 13 comes here also, is 13. This is the minimum oscillator. Here just to completeness, I have given that table. For 7, best is that you have to see that first time when it is coming. For 7, this is the better one. For 3 and 9, obviously it is this one. 1 means actually that add up all these things. This is the alternate 11 in case of 11, 1. Oscillator plus or minus 1 means this. Very simple. So that is separate. From oscillator 2, we use oscillator. Otherwise, we used full level, we used other procedures. Because we didn't notice that it is oscillation. Achha, 7, 13, 23 is here. So 23, 7 we used. Remember 7 we use here. This is the 7 we use oscillator. So 27 I did 8 minus 8. 8 minus 8 here. So that way, this repetition 91 you have to use always. Say 91 you have to use in any case minus 9. Minus 9. So that way. So this table you can see later. Using a hand. Some example is there. Yes. Testing divisibility of 842912 by 7. So do it. This is 21. So 842912. How do you do? I cut it here. This minus 2, 8428. Then again do 8442 and 8033. They become 77. 77 is divisible by 7. So therefore all these numbers are divisible by 7. Note that divisor ending on 70 is easier to use. I'm giving that you can read it. Easier to use negative oscillator instead of positive oscillator. So here actually always dividing by 5 will be bigger. In case of 17, you have to use minus 1, minus 5. In case of 17 is minus 5 because 17 into or 17 what should I do? 17 into 3 if I do, it will be 51, which is 10 into 5
Minus 5 is the
plus 1. So therefore, 5 is my oscillator, but it is negative. Minus 5 is my oscillator. So in case of 17, we have. So in case of negative oscillator, the criteria is not always divisible. It is either 0 or divisible. In case of 11 also you have seen, So in case of negative, it can sometimes go 0 also. 0 is also considered as divisible. So therefore, I given the exercise of divisibility of these things, all these things. Now I come to, because the time is less, how many minutes are there? We can take it few more minutes. Composite, this is actually, I told you already. Say 92. So I have to divide, whether 8556 divisible 92. I find that 92 is equal to 23 into 4. Now this is divisible by 4 because last two digits are divisible by 4. Okay. And then oscillator of 23 is 7 because 23 into 3 is 69 and 10 into 7 minus 1. So the oscillator is plus 7. So do like this, did like this, this again like this, 27. Then it comes to 69 divisible by 23. So this number is divisible by 4 as well as 23, so it becomes divisible by 92. Whether the same number is divisible by 93. So 93. So 93 is equal to 3 into 31. Now 8556 is divisible by 3 because 8 plus 5 plus 5, 6, 24 is divisible by 3. Okay. Here don't use oscillator because just by using principles of 3, 9, and 11. Oscillator of 31 is minus 3 because 10 into 3 plus 1 is 31 itself minus 3. So this becomes like this, and finally 62 is divisible by 31. So therefore this is divisible by 93 as well. So this is composite numbers. Now multiplex oscillator. So all the considerations, whatever you did for 10R plus U, 10 to the power n R plus UN, a block of number, yeah, it is applicable. So this is the basic method of multiplex oscillator. So algebra, if those of you want to do algebra, this thing you can do it. But what I do is procedure is that. Now it comes whether for divisor of the form 199, 299. Earlier it was single lines, but there are 2 lines now. So therefore I have to do. So I can take I can take oscillator as 20, 30, 40, etc. This is oscillator which ekajikano purbe now. This 19 plus 1 is 19, 20 into 100, 20 into 100 minus 1 is 199. So according to my principles, 19 becomes my 20 becomes my oscillator because of 199. But what I can do instead of that, I consider 2 into 100. 2 into 100 minus 1 is 199. So earlier 20 I can use my simplex oscillator or I can use 2 as my multiplex oscillator. And for multiplex oscillator, what is the procedure? Let us say whether 2196199 is divisible by 299. Now second order oscillator is 3 because second order. Why? Because this is order is that how many zeros are there? 3 into 100 minus 1 is 299. So second order, because there are 2 zeros. Second order oscillator of 299 is minus 3 plus 3. This is minus 1. Minus. Now the procedure is, how much is procedure? Let us say whether the erase. I divide it into blocks of 2. So,
Gautam ji, can we do after Pradhana, please? Thank you.
divide it into please.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महिं महिषः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकः समस्ता सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथ्वी सस्यशालिनी देशोऽयं शोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्रः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अदनः सदनः सन्तु जीवन्तु शरदां शतम् सत्यं वद धर्मं चर स्वाध्यायान् मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ओम शांति शांति शांतिः ओम पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ओम शांति शांति शांतिः सर्वे जना सुखिनो भवन्तु स्वस्ति
స్వస్తి హరి ఓం. ధన్యవాదములండి శర్మ గారు. శర్మాజీ ధన్యవాద. నౌ లెట్స్ గో ఫర్ జనగణమన.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद.
జై హింద్.
जय हिंद.
ధన్యవాదములండి. నౌ let us request Goutham ji to continue.
Actually, this group, I find it more advanced, or I have put that because they have learned this, negative method of recurring decimal. So that is a very good sign, actually. Oh. So earlier, in earlier batches, I didn't do. I thought that this negative method of this one was to be put in, in advanced, because there is so many things involved, like when it comes to negative quotient, what to do, and so on. So therefore, slightly the time is overshoot, very minorly. Earlier, I used to be finished very okay. So therefore, some part of yesterday's thing came, last day's thing came here. Acha. Now the thing is, now you understand. The thing is that it has to be in blocks. I told you in this one, blocks of n numbers of digits. Suppose it is near about 100, either 100 plus 1 or 100 minus 1. So you have to do blocks. This is my unit block. So we have to make blocks of 2 here. Similarly, something is near about, say, 5,000. 5,000. So 3 zeros are there. So you have to make blocks of 3. Something is, say, 5,000 minus 1 or 5,000 plus 1. So you have to make block of 3. Let me give an example. So yes, this one, sorry, this one was their number. Whether this particular number is divisible by 299 or not. So it is second order. Why second order? I told you that 2 into 100. Oh, sorry, 3. 3 into 100 minus 1 is 299. So 3 becomes an oscillator, but because the 2 zeros, second order oscillator. So this is so there will blocks of 2 have to make. So 55, so 55 this blocks like this. But this will not remain as it is. So like this 55 we cut it. So 21961 plus 55 into 3. This will be slightly bigger numbers, but it will be easier than the dividing the whole thing by 299 and check it. It will be easier than that at least. So it becomes 145, no, 165. And then we add up to here. It becomes like this. Again, you do cut it here. 229 plus 26 into 3, 299 division. There's so many big numbers. It collapses very fast actually because of this. This is divided by 499 or not. So again, this 42 plus 69. 5 is by because 499. 499 is how much? It is 5 into 100 minus 1. 5 into 100 minus 1. So 5 is my oscillator, but because of this second order oscillator. So we have to block up 2 we have to do. So this already I have done. This 42 plus 69 into 5. 5 is oscillator. So this becomes this. Again we cut it into this. 87 is separated. 87 into this one. This comes like that. Again this 25 is separated. 25 into 5. This one, this one. Finally it comes to 49. It becomes divisible. Now it is again then multiple oscillator negative multiple oscillator. 400 4 into 100 plus 1. 401 is 4 into 401 is equal to 4 into 100 plus 1. So therefore 4 is my oscillator, second order oscillator, negative. So minus 4 is my oscillator, second order oscillator. So again blocks up to this minus 32 into this 32 separated, 32 into 4, this one. Again 0 1 will be separated. This one, rest of the digit minus 1 into minus 0 1 into 4. Again this one, again I separate this one. 11 not divisible. This one, again this 5999. So 599 is how much? 5999 is how much? Is equal to 6 into 1000. 6 into 1000 minus 1. So it will be oscillator will be positive because of this minus. Oscillator will be 6, but it will be third order oscillator. So I have to make it block of 3. So this is divided into this one, 3 blocks. So 1928264 plus 569 into 6. So this small calculation, it will be much easier than dividing whole thing by 5999. So this becomes 6, 5, plus this. Whether this big number is divisible by 7 and 111. Again, it will be third order oscillator, 3 digits are there. This 0, third order oscillator will be minus 7. So this is the one. We cut it like this. So into this minus into this one, minus 7 is oscillator. 597, this one that way, it collapses to 0. That means it is divisible. Either 0 or divisible. Whether in case of negative, using negative oscillator, I told you already, either 0 or divisible is the criteria. So this in short, you can see, you can look at it. Now, there are some numbers called repeat 9. 10 to the power n minus 1 numbers. Multiplex oscillators are 1. Like in case of 9, it was simplest oscillator was 1, and we added up. Here also we add up, but in blocks of 2. Earlier we did everything in block of 1, means we didn't notice. Everything we added up and divided by 9, whether it is divided by 9 or not. In case of 99, this is repeat 9 of length 2. So it is, you have to divide by, this whole thing is divided by 99 or not. You separate it into blocks, because now there is no more multiplication within oscillator, because it is 1 only. You do not notice any multiplication, but actually there is multiplication there. Same principle. Principle is same. But since 1, you don't have to do anything. You simply, like 9 you did, in block of 2 you do it here, 99. Whole thing is triple 9 or not. So you block of 3. Block of 3 add up. Block of 3 from right, mind it. Do not make it from left, then it will not be done. 99. The whole big thing is divided by 999 or not. So I do block of 4. There are 4 9s. The block of 4. Okay. That is right. This is it. Repeat 9 numbers, special cases where nth order multiple oscillator is 1. Because 9999 is how much? 999 is equal to 1 into, oscillator is 1. But what order? 1 into 10,000. Okay. Minus 1. This is this one, 9999. So its oscillator is plus 1, but 4th order oscillator. So we have to cut it by 4 blocks of 4 from right. And divide every time multiply by 1. Oscillator is 1. So it is, instead of doing so complicated, we simply say that, tell that it's simply blocks of 4, you add and then test divisibility. So this is the idea. Similarly, something called hollow number. Earlier it was 10 to the power n minus 1 numbers. These are the hollow numbers are 10 to the power n plus 1 numbers. So whether this is divisible by 1001 or not, 1001. So it is oscillator is minus 1, but block, this is 10 cube, means there are 3 zeros. 3 zeros plus 1. So there are block of 3. So like in case of 11 we did 1 positive, 1 negative, 1 positive, 1 negative. Similarly here. This 229 not different. See, what to do? This one is divided by 1001. This one again positive, negative, positive, negative. It is same as add up all the positions and add up and then subtract. Like we could have added up this one and this one, this one, and this one with this one, and then add and subtract. Like in case of 11 we did. Same thing has to be done by for hollow numbers. 11 is a special case hollow number where there is no zero in between. But it is also same category. 10 to the power n plus 1. 10 into so here this is 0. So therefore it is divisible. The whole thing is divisible by 1001. So you imagine that you have to giving the task. So you have to divide by 1001. It will be very long. So obviously this will be marked easy. So this big number, you cannot even pronounce it properly. How much 10 to the power how much? But whether it is divisible by 10,001, so you cut it into, this is actually 4th order. So 4, because 10,000 plus 1, 10 to the power 4 plus 1. So here it is alternate again. 1, 2, 3, 4. Here like this. Like this, like this. You cut it like this in blocks of 4. And then in case of 11, what you did? Similar thing you have to done. You have to have done. This 1 month plus 1 month. Or you can do this plus this plus this plus this on one side, and this plus this plus this plus this one side, add up and subtract, like in case of 11 what you did, and then it becomes to 0. So the whole thing is divided by 10,000. Hollow numbers are special cases where nth order multiplex oscillator is -1. The process leads to alternate addition and subtraction of digits grouped in n, like we did in 11. Similarly, repeat 9 numbers are special cases where nth order multiplex oscillator is are 1, which leads to simple addition in groups of 9 n digits, like what we did in case of 9. So this thing. Now comes it where there is some factorization there. So here we find that divided by 857. We find that it is a little difficult. These are to be done by advance. 7 into 857 is 5999. So third order oscillator is 6. I didn't do this, but you can try this thing. So therefore, if it is divisible by 5999, obviously it will be divisible by 857 also. But there can be smaller number which is not divisible by 899 but divisible by 857. It can be all got by this.
Gautamji, you want to, how much time you would like to take?
Yeah, that is over. Just the people say that it is the last slide.
Or
So
if
you
you,
understood that how the factors also can be done?
if you want one more session, we will plan later.
No, it's not that critical. It is already the last slide.
Okay.
So what I mean to say that the same multiplication oscillator you can do apply bigger numbers. They are all handling bigger numbers. This is this thing. So fourth order oscillator is 3. So you have to only understand this concept. This thing is clear? Any question?
For doubts clarification, at what time can we talk to you by WhatsApp, sir?
Anytime you put me WhatsApp.
Anytime means okay.
But away
You
to
can put WhatsApp. I'll see. Actually, I have a lot of group. Actually, sometimes your gets below. I can search it, and sometimes after searching, I get it, and then.
Okay.
but
Thank
now
you.
you may be busy with the puja, isn't it, sir?
That's
No.
what,
In between puja also I can look at, no problem. I can look at WhatsApp and answer, no problem. Even in sitting in near puja, I can do also. I do also like that. I get always the exam involved in this thing.
Very nice.
Yeah. So
okay.
these are the things. You understand the order? What I'm telling. Order means actually how many zeros, then plus or minus 3 into 10 to the power 5 here. So therefore fifth order. And 4 into 10 to the power 5 minus 1. This is number. So 4 is my oscillator, fifth order. And it is -1, -2, it is positive. So that way it comes like that. Okay.
Yeah. For students,
These are the, you try this one?
Yeah.
You try this one? This thing you try?
So for the students in examination point of view, the previous page, that is very important. This page is very important to understand.
Very important. You will be given.
Oscillators and order of oscillator.
Yeah, exactly.
So
You understand this very clearly.
yeah.
There will be exams. There will be exam.
Yes. So understand this page very well, so that you can fare well in the exam. Okay. Okay, Babugar, I think you can close now.
Okay.
Gautamji, thank you very much.
Namaskar.
फिर
Thank you
मिलते
very
हैं।
much.
Okay, now in that case, I'll stop recording.